So I've got a vector field here, v of xy, where the first component of the output is just x times y, and the second component is y squared minus x squared. And the picture of this vector field is here. This is what that vector field looks like. And what I'd like to do is compute and interpret the divergence of v. So the divergence of v as a function of x and y. And in the last couple videos, I explained that the formula for this, and hopefully it's more than just a formula, but something you have an intuition for, is the partial derivative of p with respect to x. And by p, I mean that first component. So if you're thinking about this as being p of xy and q of xy, q of xy. So it could use any letters, right? And p and q are common, but the upshot is it's the partial derivative of the first component with respect to the first variable, plus the partial derivative of that second component with respect to that second variable, y. And as we actually plug this in and start computing, the partial derivative of p with respect to x of this guy with respect to x looks like a variable, y looks like a constant, the derivative is y, that constant. And then the partial derivative of q, that second component, with respect to y, we look here, y squared looks like a variable and its derivative is 2 times y, and then x just looks like a constant, so nothing happens there. So on the whole, the divergence evidently just depends on the y value. It's 3 times y. So what that should mean is if we look, for example, let's say we look at all points where y equals 0, we'd expect the divergence to be 0, that fluid neither goes towards nor away from each point. So y equals 0 corresponds with this x-axis of points. So at a given point here, evidently it's the case that the fluid kind of flowing in from above is balanced out by how much fluid flows away from it here. And wherever you look, I mean, here it's kind of only flowing in by a little bit, and I guess it's flowing out just by that same amount, and that all cancels out. Whereas, let's say we take a look at y equals, I don't know, like 3. So in this case, the divergence should equal 9. So we'd expect there to be positive divergence when y is positive. So if we go up and y is equal to 1, 2, 3, and if we look at a point, I don't know, let's say around here, and we kind of consider the region around it, you can kind of see how the vectors leaving it seem to be bigger, so the fluid kind of flowing out of this region is pretty rapid, whereas the fluid flowing into it is less rapid. So on the whole, in a region around this point, the fluid, I guess, is going away. And, you look anywhere where y is positive, and if you kind of look around here, the same is true, where fluid does flow into it, it seems, but the vectors kind of going out of this region are larger. So you'd expect, on the whole, for things to diverge away from that point. And in contrast, if you look at something where y is negative, let's say it was y is equal to negative 4, it doesn't have to be 3 there. So that would be a divergence of negative 12. So you'd expect things to definitely be converging towards your specific points. So you go down to, I guess I said y equals negative 4, but really I'm thinking of anything where y is negative. And let's say we take a look at like this point here. Fluid flowing into it seems to be according to large vectors, so it's flowing into it pretty quickly here. But when it's flowing out of it, it's less large. It's flowing out of it just kind of in a lackadaisical way. So it kind of makes sense just looking at the picture that divergence tends to be negative when y is negative. And what's surprising, what I wouldn't have been able to tell just looking at the picture, is that the divergence only depends on the y value. That once you compute everything, it's only dependent on the y value here, and that as you go kind of left and right on the diagram there, if I go up, as we look left and right, the value of that divergence doesn't change. That's kind of surprising. It makes a little bit of sense. You don't see any notable reason that the divergence here should be any different than here, but I wouldn't have known that they're exactly the same.